one is known as plane strain. Okay, so if again I draw our transformation, so x, y, and z. Okay, so the first thing I'm going to explain is what do I mean by plane stress. Okay, so if we have an element and the element, if we have a stress state that's acting this way, this will be our stress x, this will be our stress y, and this direction will be our stress z. Okay, so in plane stress condition, okay, it can be either one of this. Okay, where stress x and stress y is not equal to 0, stress z is equal to 0. Okay, so this is number one. Or it can be in a second situation where stress x and stress z is not equal to 0. So from here, stress y is equal to 0. Okay, or condition number 3, where we have stress y and stress z is not equal to 0, stress x is equal to 0. Okay, so in plane stress condition, okay, one of the stress state will be equal to what? Be equal to 0. Okay, so that is what we call plane stress. So if you see any analysis later on that we make, and when we assume plane stress, means immediately comes to your mind is one of the stress state is equal to what? 0. Okay, so the next thing that we're going to do is a concept or an analysis which we call plane strain. Okay, so some of you might, Eugene, what is a stress and strain? Okay, so if you look at a stress strain curve, right? So epsilon over here is strain, and this is our stress. Strain is usually calculated in a change in length divided by original length under axial loading. Okay, where stress is equal to force divided by cross-sectional area. Okay, so again, we have the same element. So with the term defined, we know that when it's stretched in this way, this is known as epsilon x, epsilon y, and we have epsilon z. Okay. So in plane strain condition, when we do analysis in plane strain, okay, what it actually means is strain in x direction and strain in y direction is so much bigger than strain in z direction. However, stress in z direction is not equal to 0. Okay, so that's the difference. Okay, that's the difference between plane stress and plane strain. Okay, So for plane strain, okay, none of the stress state is equal to 0. Okay, so condition 2, strain in X and strain in Z is so much greater than strain in Y. Okay, however, stress in Y is not equal to 0. Again, the last one is strain in Y and strain in Z is so much greater than strain in X. However, stress in X is not equal to 0. Okay, so in plane plane strain condition, okay, none of the stress state is equal to 0. So that is the difference when we come across plane stress and we come across plane strain. Okay. Okay. So now we are going to look into normal stresses. Okay. So we are going to look into normal stresses of an element. Okay. So now we have. So we are going to now do 2D. Okay, we're not doing 3D yet. Okay, we are going to look at a 2D now. Okay, so again, this is our X and this is our Y. Now, in real life, our world is always in 3D. Okay, our analysis is always in 3D. Okay, but to do 3D, we have to understand the concept in 2D first. Okay, only after you understand the concept in 2D, okay, when you do 3D, the principles are very similar. Okay, so we're going to do 2D first. Okay, so we have an element over here, right? So this is our element. Okay, so stress X is our normal stress. Okay, and stress Y is our normal stress also. Okay, and why is that? Because on the surface, this is what 90 degrees. So that is our normal stress. Okay, so stress X is the normal stress acting in the X direction. And then stress Y is the normal stress acting in the Y direction. Okay. So we are going to state that stress X is greater than stress Y. Okay. And once you have seen an element, I want you to label this surface X, and over here surface or point X and point Y. Now these are for Mohr circle. Okay. So now I'm now going to sketch Mohr circle now. Okay, we're going to sketch Mohr circle now. Okay, this is just a sketch. So on Mohr circle, our x-axis, we have an x-axis. Okay, and then we also have a y-axis. So the x-axis is the normal stress, right? The y-axis is the shearing stress. And I want you to have the habit of doing this, okay? The shearing, you draw this rotating in clockwise at the top. at the bottom is anti-clockwise. Okay, have the habit of doing this first. Later on, I'll explain to you why. Okay, so this point is 0. Towards the right is positive, means it is what? The normal stress is tensile. Okay, towards the right. Towards the left, okay, is negative. Negative means it's under what? Pressure. Okay, so one is under tension, the other one is under compression. Okay, so from here on this element that we just state that the normal stress X is greater than normal stress Y, and both are what? They are pointing away, right? So when they are pointing away, it is tensile, means it's stretching, and it's pointing up. Okay, this is also what? Tensile. Okay, so we declare that stress X is greater than stress Y. So now I'm going to draw. Okay, I'm going to sketch. I'm going to draw a line. So this is our stress X line. And then we are going to have our stress Y line. Okay, and you see, when you see this, the element has no shearing stress at all. So i.e., at this location over here, where shear is equal to 0, right? If you look at this, shear is equal to 0, right? So this is our point X. Over here, that is our point X. And over here, this is our point Y. Okay. So from here, we can immediately sketch our 2D Mohr circle. So this is our 2D Mohr circle. Okay. So this circle over here is for the XY plane. Okay. And exactly at the center of the circle, okay, you label this as point O. Okay. And then when you draw a vertical line down, passing O, right? This distance from here to here okay, this is known as your stress average. Okay. So stress average formula is really straightforward. So stress average is also equal to the center of circle and is also equal to stress X plus by stress Y divided by 2. Okay. So that's how you calculate the center of circle. Now, I want you to look at something. Okay. I want you to now focus at X, Y. Okay. So the angle, right, from point X to point Y, okay, so from point X to point Y, this angle is equal to 180 degrees from point X to point Y. Okay. If you look at the element from point X to point Y, this is 90 degrees. Okay. So what does it mean? Okay. So on Mohr circle, when the angle is to theta, okay, in the element, or on the element, the angle is theta.